Hey everybody. You can take a look at the problem on the screen. Here's number 22 from your practice. It's a bit of a challenge problem, and really it's meant to give you an idea of how to extend your algebra skills with respect to expanding or multiplying. I'm going to tackle 22a. So it says write, expand, and simplify an expression that represents the area of that square. It explicitly tells you up top that the side length of that square is a plus b plus c. So if you were going to calculate the area of a square, then you would take its side length and square it. Or you would end up taking its side length and multiplying it by itself. So in either instance, that's what we're going to kind of work towards. I think for us to be able to say then that it is a plus b plus c all squared, I think is useful. Now, when you're working your way through, if it was a perfect square, let's say with a binomial base, I would expect you to be able to go through and expand that and simplify in one step. However, as soon as our base is not a binomial and it becomes something a little more complicated, look at your base there, it's a trinomial, then I think you should end up going through. I think it's easier to visualize that base multiplied by itself. That'll just help you maybe to be able to make sure that you go through and you deal with every single instance. So the picture up in the top right corner is meant to give you an idea of why you get the answer you get. So what I want to do is I want to go through and I want to expand that blue, and then we'll use the picture to confirm. So you can work your way through and you could say, okay, I need to take everything inside the first bracket and multiply it by everything inside the second. So if you see those arrows on the red, that's what I'm going to work through. I would then have to take my B all the way through, and lastly my C all the way. Yikes, that gets pretty ugly. That's okay. So we take our time slowly to ensure we have every single term. Okay, let's go ahead and expand it. So if I multiply my A in towards everything else, I have my A squared plus an AB plus an AC. I then have my B multiplied by everything. So there's an AB plus a B squared plus a BC. I then have my C times everything. So an AC plus a BC plus a C squared. Make sure that's a plus. And there we go. Now we go through and we collect any like terms that we have. You'll notice that you do not have any other squareds that are like terms. So you would have like an A squared plus a B squared plus a C squared. That is going to take care of, if I just shrink that a little bit, all of your squared terms. Then you can go through and you can look for any variable terms that have the same variables. Well, you'll notice you have like an AB plus another AB. So we end up getting two ABs out of that. I'm going to get rid of those circles. That takes care of them. You'll then notice that you have an AC and an AC. So there's two ACs. And then I can get rid of that and make sure that I've got everything crossed out that I need to. My ACs are crossed out. And then you notice that you have BC terms, a BC and another BC. And so that gives you two BCs. You'll notice that then I've dealt with every single one of my terms. That is fully simplified. Now, I'm hoping that you recognize a little bit of the patterning from what you would have had with a binomial perfect square. But let's take a look at that breakdown for a second. What you end up getting is the squareds of each individual term, and then you get the combinations of any two terms in its base. So what am I talking about? Go back up and look at the purple expression I wrote at the very beginning. You'll notice that we have to pair up the A's and the B's. You then have to pair up the A's and the C's. You then have to pair up the B's and the C's. And so it's every combination of those three variables, the parts of the base. And if we can examine it that way, then I think you might be able to go ahead and take that purple statement and go straight down to a final expression. Okay, take a peek up in the top right corner. I want to make sure you're good with y. Look at your picture and you will see all parts of your area. The first box that I'm just shading in red, and I'm only going to do this for a few boxes, that is your a squared. That is your square with the dimensions a by a. So if I got rid of that highlight, you could then take a peek and you could say, hey, well, this green shaded in square is an a by a b. But you'll notice that you have another a by a b rectangle here. And so when we add everything together, you would have two ABs. And so you can start to work your way through each individual rectangle or box, and you can see how that bottom expression represents the expression of the entire square. Okay, I'm hoping that that could be a fast way for you to go through. I'm going to now do it in one step. So I'm going to get rid of all of this stuff, and I'm going to work just with the purple. If I needed to expand that in one step, then what I can do is square all of the individual parts of the base. Remembering, though, that I would have all these other middle terms, if you want to think about it, my combination terms. I would have 2 of the ABs plus 2 of the ACs. And what's the combination I haven't used yet? My B's and C's. There we go. So there is a fast way to be able to go through. Your job, and I'm going to leave you with it, is I want you to go ahead and try to now expand that perfect square using that shortcut. Okay? I want to be very clear. There is no expectation at all that you learn that shortcut. None at all. You notice the first way we did it, we never used it. Okay? I'm hoping that helped you with your practice. Best of luck with the rest.